Hello everyone. Today we are working on STATA, a powerful statistical tools or software for data analysis, data management, and data visualization. So it's widely used for research, economics, and public health related tasks. Okay. So with the STATA, you can type the commands and use menus to quickly calculate the descriptive statistics or any statistics, create the different types of graphs, and run different types of tests. Okay. So in this tutorial, I will input a data set and answer three practical questions with the sub questions and the other things, and I don't only the write down the code only, so I will interpret the output also. Okay, then you can use it. So the thing is that first of all we have to import the data file, so we have to go to file menu, then open, okay, or any data file where basically I put the data file. Okay, Gallbladder is my data file. Here is the id name or variable name. So here is the variable name and the data label also. Okay, what does it mean? id means identification, gbd means diagnosed with gallbladder diseases, and bmi body mass index, age of the patient, achieve education or not, something like that. Physical activity, whether they do physical activity or not. Type 2 diabetes. Okay, so here's the data preview. I can see the data here. Okay, here is that data editor tab. Okay, or options, you can see. I can download. So the first question was like, calculate the mean, standard deviation, minimum, maximum of values of bmi for body mass index. So I know I have the variable like bmi here, so I have to write down the code. Sum for summarize, sum bmi comma d for details. Okay, so here everything we can see about the bmi. Okay, so here is the mean value, here is the standard deviation, here is the median value, and here is the 25% first quartile, third quartile. Okay, so average on the median value is indicating the second quartile also. Okay, so here is the skewness and kurtosis. Okay, everything we can see in details here. Okay, the second question was, create a box plot to illustrate the distribution of bmi, median, mean, and maximum. Is insert the box plot below. Okay, so here the second question is like, I have to make a box plot for bmi. So here we can write down the code, graph box plot bmi. Okay, so here automatically it will conduct the box plot. Okay, so here we can see easily the box plot. Here is the whisker. So outside of whisker we can see the some outliers here, and the first quartile, median, and third quartile here. So everything in details here. So you can see the data distribution here. Okay, and the third question was like, check whether there are any outliers or not. Okay, so here we can see the some outliers here. Okay, so here the set A was like the prevalence, what is the prevalence of gallbladder disease in the study population. So for this we can tabulation for for tabulation or tabulate. Okay, for gbd. So here we can see how many people basically have the diseases, yes, and how many don't have the disease. Okay, so here is the 209, that means 15.27% indicating they have the diseases. Okay, and 209 people they have the disease. Okay, so the second question of second sub question of question 2, how many patients with gallbladder disease have only primary division. So here we can do tab. Here we can contact the cross tabulation gbd, bd, and edu for primary education or something. Okay, so here we can see the only people who have the primary education and who has the who basically have the diseases. Okay, 40. Okay, 40 people who basically have only primary education, and they are the patient of diseases. Okay, the third question was, what is the mean age and standard deviation of participant without gallbladder diseases. Okay, gallbladder diseases. So for this code, first of all I have to write down the by code by gbd basically indicating the which is the categorical variable have. Now then comma sort clone sum for summarize, clone sum for summarize, and age comma d for details. Okay, sum for summarize by GBD, basically yes or no they are patient or not. Okay, so here we can see every output here. Here the people who basically answered no, they are not patient, GBD. What about the scenario, the 25%, 75% people they are basically less than or equal 67, 50% people are basically age on average 63, and here is the mean value 62.82. That means the average value, standard deviation, on average the distance between the mean. Okay, so here is the who people basically answered yes, they have the these ages, and the mean value average, the median and the mean, something like that. Okay, 75%, 25%. 3a, what is the mean BMI for participant with and without type 2 diabetes? Okay, so for this, by T2D for diabetes, here is the diabetes, comma sort clone sum for summarize, BMI, comma for details, comma D for details, comma D for details. Okay, so here's some same thing again, but this is the based on the BMI and the type 2 diabetes. Type 2 diabetes, no, who basically answered no, their mean BMI is 25.45. Those who answered yes, they have the diabetes, their mean BMI is 27.183. okay, that means there is some slight difference between the BMI based on the diabetes also. Okay, so the second question was like, is there any difference in BMI between the two groups statistically significant? What is the p value? Okay, is there any significant difference between the BMI of type 2 diabetes or not? So if we want to find out is there any significant difference or not, something like that, so here the category variables have two levels, diabetes yes or no. Okay, that means two levels, and we want to find out the is there any significant difference in mean between the two levels. Okay, so we can find out the null hypothesis, there is no difference, and alternative hypothesis is there is a difference between the between in mean between the two levels. Okay, so for this we have to write down the code t test BMI, comma by parenthesis type 2D variable name. Okay, so here is the p value output, here is a two tail output, like there is a difference or not, something like that. Here is one tail, here is the one tail. So we have to focus as the we want to find out is there any difference, significant difference or not. So we have to focus on that, the p value, here the p value is 0.00, something like that, and we can see the mean value of BMI, yes or no 25.45, and the no is yes is 27.18. so here we can see that there is something difference, the difference value is minus 1.7288, something like that, and the p value is indicated, then there is a significant difference between the BMI value. Okay, between the type 2 diabetes also. Okay, so here is the output, here is the interpretation, and what type of analysis basically we use here, we use independent sample t-test, because the categorical variable have two levels only. If the categorical variable have three levels, then we have to conduct one way ANOVA, but here the categorical variable have two levels, and we have to conduct the independent sample t-test also. Okay.